Okay? The reason why we're taking this little detour into rational expressions is because we're going to be building up. We're going to be doing polynomial functions after this, and then rational functions after that. So we need to know what a rational function is and how to deal with a rational function and write it and manipulate it before we can actually use them and analyze them, all right? So it seems like a really good time. It'll be a short unit. It's only about 4 days long, okay? We're going to have a couple days of notes. We're going to review pretty good, and then you're going to have another test, so it's going to happen pretty quick. This first test has taken a while. The next test is going to be like right up on top of you, and then after that we'll go to polynomials, which is more function stuff, which will mean you'll just get even better at it. So let's talk about what is a rational expression. A rational expression is a ratio of two polynomial expressions. Basically, we call it something along the lines of, usually I'll say P of X over Q of X. Okay? P of X over Q of X. An example of that would be a polynomial. A good example would be like 5x plus 2 over 13 plus x. That would be an example. Ratio means fraction, doesn't it? It could be negative 3 over x plus 4. 2x plus 4. That would be an example. It doesn't have to have an exponent, or it doesn't have to have a variable in the top numerator and the denominator, but it does have to have it somewhere. Okay? That would be a guy. So now, it says, under what conditions would the expression from your example be undefined? When can we not define something that is a fraction? Zeros where? Okay. So when the denominator equals 0. So let's look at when the denominator equals 0 for each one of our expressions, example expressions. So where is the denominator in this first guy over here? 13 plus x, right? That's the denominator. So to find where we have undefined places, we simply take the denominator, set it equal to 0. Okay? So we're going to take 13 plus x and set it equal to 0. So x cannot be what? Negative 13. So when x equals 13, that thing is undefined. So now how would we treat the second example?
Wait, when x equals 13 or when x equals 13?
Or negative 13, excuse me. If we plugged in negative 13 over there, we'd get 0 in the denominator and we couldn't divide. So how would I treat negative 3 over 2x plus 4? How would I find out where it's undefined?
Set 2x plus 4.
Yep. So that means 2x equals what? Negative 4. So x equals, yeah. So we know that x cannot equal negative 2 for this guy, and x cannot be negative 13 for that guy. Now, when we are dealing with rational expressions, sometimes we have to start by factoring them and getting rid of common factors, okay? GCF is your greatest common factor. So take a look at the first example right here. Do we have a common factor?
Yes.
Yeah, we do. Obvious one right here. We have a common factor. So now we can write this as 2x over x squared minus 1. Now, we really need to put this in its fully factored form, because we're going to want to be able to figure out where it's got places in the domain we have to say it can't be. So if we were to factor this, what would x squared minus 1 factor into?
X plus 1.
Yeah. X plus 1. It's difference of two squares, right? X plus 1, x minus 1. So what that's going to tell me is, notice what it says underneath. Under what conditions is this expression undefined?
X cannot equal positive.
Yep. So we'll take the x plus 1 and say it cannot be 0. And we'll take the x minus 1 and say it cannot be 0 and solve. It's just that easy. So x can't be 1 or negative 1. So if we were to write that in domain, let's do this in interval notation. Our domain would be from negative infinity to where? Negative 1, right? And then from negative 1 to 1, and then from 1 to infinity, right? I know. You got two gaps and it makes this big long statement, interval statement, doesn't it? Just go from left to right. Just think about it from left to right. Okay, I'm going from negative infinity. I'm going to hit negative 1. Nope. So I stop there. I'm going to go keep going from there to 1. Got to stop. Can't have that. And then I'm going to keep going. And that'll, if you'll picture that in your head, it'll help you write those three statements, okay? All right, so let's look at the next one. Do we have a greatest common factor we can get rid of? Yes. Nobody is tempted to take the y out or the 3 out, right? You can't pull it out of anything unless you can pull it out of everything. So, figure out what your undefined places are going to be and then write your domain statement, please. Go ahead and do that now. Rewrite this. So what's the answer here going to be? 3y over what?
3y over y minus 3y.
Yep. So now do your undefined places and write your domain. So how do we feel about this so far? Taking the pieces of the denominator, saying they can't be 0, and then taking those out of our statement. Okay? All right, so here's our quick check. These quick checks, by the way, are part of your homework. We're going to do 2 of them, and you'll have to do 2 for homework, okay? So let's look at this guy right here. How do we deal with it if it's not factored already? What can I pull out of 70xy cubed over 35x squared y? Deal with the numbers first. Are there common factors between 35 and 70? 35 will go into 70, won't it? Okay, so 35 goes away, 70 goes away, and what's left?
Then you can take your x out.
Okay, I can take an x out, and that gets rid of the square part, right?
Right.
All right. And then can I remove any y's?
Yeah.
So I'll take y out, and this becomes a squared. So what's left in the top is a 2,
2y squared.
and what's left in the denominator? Okay, so is there any place that I have to leave out of my domain in the denominator? Yes. Even if there is just an x, you have to say it cannot be equal to what? So we still have to say x cannot be 0, so what's our domain going to be here? And then from, yep, good. All right. So now let's look at the other one. Look at x plus 3 over x squared minus 9. Can we factor any of this? Okay. So we take x plus 3. What are we factoring x squared minus 9 into? Difference of 2 squares, right?
X plus 3 is 6.
So if we do that, is there anything that cancels out? Okay, so here's where people make goofy mistakes. Some of you are just going to tell me the answer is x minus 3. Why is that wrong? That's in the denominator. So if everything in the numerator goes away, what stays? What do we put in the numerator? A 1. Yep. And so we take this here and we say x minus 3 cannot be 0, so x cannot be 3. And if you want to skip that x minus 3 cannot be 0 part and just write x cannot be 3 because you can see it in your head, fine by me. You're in pre-cal now. All right, so what's your domain going to be? Yeah. So as you can tell, and sometimes if you look at the one just below that, you can tell you're going to have to factor both the numerator and the denominator, aren't you? So those two problems are going to be homework. So these two are homework. So you can just put a star next to them, okay? So here we go. How about what happens if we have to simplify? Let's do some more problems here. Simplifying by factoring out a -1. We're still going to be factoring here. It's still more factoring practice. So what can I factor out of the numerator here in the top? X squared. What's left then? Minus. Yeah, you can't lose a spot. Remember, it has to be able to. So now what about the bottom? X cubed, and what am I left with? 1 minus y. Do you notice, do you see why we're saying you're going to have to factor? What do you notice here and here? They are switched around, aren't they? So here's what we have to do. If we pull out a negative here, then what does that do to the signs inside? Switches them. So if it switches them, then I'm left with x squared times y minus 1 over negative x cubed, and this becomes y minus 1, doesn't it? So if the order is the opposite, if the signs are opposite, if you pull out a negative, you can switch it around. Now that I've got it switched around, do I have any common factors I can get rid of? I can definitely get rid of y minus 1, and what else can I get rid of? Okay, so what am I left with here? -1 over x. So be careful. And that negative needs to either go in the top or out to the side. Okay? Don't leave it in the denominator. It's bad math. All right, so what can x not be equal to? 0. So our denominator, we can put all this down here. Our denominator is going to be what? I'm sorry, domain, yes. Okay. See if you can do the next one. See if you can factor out. And figure out your conditions where it's undefined. Ooh, we made a mistake on this other one. Oh, it's bad me. need to fix that. All right, so let's look at this one. Is there something I wasn't thinking of that we need to think about? All right, so did you get negative x as your answer? Okay, so when you looked at it, did you say, well, the domain must be all real numbers then, because there's nothing in the denominator? Here's the thing. Anything that was ever in the denominator, guess what? We have to account for as holes in the denominator, as holes in our domain. So I had to, even though they factored away, I had to put them down there, okay? So anything so that's why I said we made a mistake right here, didn't we? What did I forget to put? That y minus 1, didn't I? So we have to account for those factors that disappear, too, as holes in our domain, okay? Even factors that factor away, common factors have to be accounted for. So that really makes our domain from negative infinity to 0, 0 to 1, and then 1 to infinity. So be careful about that. Make a big star here that if it ever shows up in the denominator, it is a factor that we have to take out of the domain. Got to be careful with that stuff, don't we? And then you have 4 for your homework. Why is it x cannot equal 1? For that one? No, but it's not minus 1. For it to be x cannot be 1, it would have to be x minus 1 equals 0. And if it's in the numerator, we don't even mess with it. Only stuff that's in the denominator, only factors in the denominator gets that equal to 0. Good question, though. Okay. So, any questions on how we simplify by factoring out negative 1? We only pull out negative 1 when they're exactly opposites. A factor is exactly opposite, like y minus 2 and 2 minus y. Okay? All right. Can y'all factor that one? Can y'all factor the denominator in that one? How confident do y'all feel about factoring trinomials? Good? I hope. Okay, good. Oh, hey. All right, so multiplying rational expressions. What are we going to do to multiply? We do numerator times numerator, and we do denominator times denominator, right? This is not cross multiplication. You'd be surprised how many times people think this is like an equal sign and they cross multiply. You do not cross multiply here. If we have a over b and we multiply it by c over d, what do we get? A times c over times d. So ac over bd, right? So it is straight across after we simplify. So it says, how do we multiply rational expressions? First thing, step 1 is factor. Step 2 says cancel out terms that are common factors, okay? Anything in the numerator can cancel with anything in the denominator, whether it's in the same expression or in the one next to it, as long as it's multiplied. So we cancel out terms that occur in the numerator and denominator, and then we write our answer in simplest form. So let's look at an example. 4x over 5y times 15y squared over 16x cubed. So, step one would be to factor. There's really no factoring here, is there? Then we go to step two and we say, can we cancel terms out? What terms can I cancel, guys? What terms can I cancel?
A y and an x.
Okay, so we can pull a y out here and this goes. I can pull an x out here and this becomes an x squared. What about numbers? Numbers go too.
4.
4 goes into 16 how many times?
4, 4.
And then
No, 5.
5 comes out.
3.
Okay, so now we have to see what's left in the numerator.
3y.
And then what's left in the denominator? 4x squared. Now we got to go through. Notice it doesn't say we have to find things that can't equal 0. Unless we've got factor groups, we're not going to mess with this if we have more than one variable. We only deal with the x cannot be y, cannot be whatever if we have one variable, all right? Don't worry about it otherwise. So this would be our final answer, okay? So why don't you try this first one right here, and then the other 3 will be homework. If we finish this lesson fast enough, you can just work on your homework, which I think we will. It's actually not that bad. All right. It'll go fast. And then check your answer. And always double check your numbers to make sure that if you skip something, like you'll notice that I didn't catch it until I had written it out again. I was like, oh, wait a minute, that'll go into that. Some more. So how do we feel about this so far? Need a little more practice? Okay. Why don't you try the next one too? And that way you can do the other 2 for homework. We got the time. Let's just go ahead and every one we do together, you don't have to do for homework. All right.
There's no homework sheet with that. It's just like
No, it's just embedded in. Yeah. Did you get it? And guys, there's never an excuse to not get those numbers right, because the worst case scenario, you could take negative 2 times 7 in your graphing calculator that does fractions, right? Divide it by 9 times 28 and then put it back in fraction form, and it will give you a reduced fraction, won't it? Did you think about that? You understand what I'm saying? You've got a tool right here to reduce any fraction you ever need to reduce if you aren't good at it yourself. Matter of fact, that's what I'll do. So second y equals, I'm going to do negative 2 times 7 in the top. Divide that by 9 times 28. Hit enter. Gives me negative 1 over 18. This is what that is, right? And then all you have to worry about is the variables. Okay? All right. So are we good? So let's cruise on. Dividing rational expressions. Dividing is just as easy because all you're doing is putting them in terms of multiplying. Do you remember how we divide fractions? Dividing one fraction by another, we flip the second fraction and we multiply. So if you can do what we just did, you can do this. Okay, so dividing fractions, we simply multiply by the reciprocal. In other words, AB divided by CD is the same as AB times what? Yep, keep, change from division to multiplication and flip, so it becomes D over C. So AD over BC. So let's look at this. It says, how do you divide a rational expression? Rewrite as multiplication. Factor. Cancel out the terms and then write in simplest form. After step 1, aren't the next 3 steps the exact same ones we did for multiplying? So once you switch it, now you're just doing the multiplication thing again. So let's look at one of those. Let's look at 10xy squared, 3a squared b divided by 5xy over 6a squared b squared. So the first thing we need to do is rewrite this, don't we? So let's rewrite this. So the first one stays the same, 10xy squared over 3a squared b, only times now what? So we are simply flipping this, aren't we? Now we can do our thing. Good practice for you, so go ahead and reduce this thing. What can we reduce? I always start with the numbers. 3 will go into 6, right? Okay. 5 will go into 10. All right, we got some x's, so I got an x and an x. I got a y and a y squared. I got an a squared and an a squared, and a b and a b squared. Now, the only thing you really need to be careful about is that you don't lose things when you're reducing all this stuff, okay? So what's left here? We got a 2 times 2 is what? And then I got a y here and a b here. So 4by. I always do alphabetical order. And then in the denominator, I got nothing, do I? So 4by. How do we feel about this? Why don't you try this guy and see if you can get it. All right, guys. Work on that. Oh, good.
What, all three that X's cancel?
No. You've got one x in the denominator. So that only gets rid of one x. Because think about it, x times x would be x squared, wouldn't it? So you got one x in the denominator and x squared in the numerator. So just pick one of them. Good question, though. So what'd you get? Someone be brave. Give me an answer.
Negative X squared.
Yes. Negative 9x over y. You lost at 9 somewhere.
Oh, I literally completely forgot.
Oh, oops. Yeah. You gotta flip. All right, so the other three are homework questions. All right, so let's move on to what if we have polynomials? If you have polynomials, multiplying rational expressions with polynomials, that means step 1 is factor. Step 2 is cancel terms. Step 3 is rewrite. These are the same steps for doing anything, aren't they? The only difference is how we factor is a little different. So let's look at this. If we have x minus 3 over x plus 1 times 1 minus x squared over x squared minus 4x plus 3. Okay? So let's look at this. Can we factor anything in the first part? These are already factor pairs, aren't they? However, can we factor the second part? 1 minus x squared is a difference of 2 squares, isn't it? All right, so what would it factor into? Now, you're tempted to say x minus 1, x plus 1, but it's not. It's backwards, isn't it? So it is what? 1 minus x, yes. Now, x squared minus 4x plus 3 factors into what? Yep, x minus 3, x minus 1. All right, so let's start flipping things or doing stuff that we can. Any obvious ones that we can get rid of? And what else? X plus 1, 1 plus x. Is there any order in addition? Does order matter in addition? What's 2 plus 3? What's 3 plus 2? So order doesn't matter. So if we have 1 plus x or x plus 1, they're the same, aren't they? However, does order matter in subtraction? Yes. So I've got 1 minus x there and x minus 1 there. What do I have to do to get those to match? What's our trick for getting the, pull out a negative? So this becomes negative, doesn't it? So now, do I have any other factors that will get rid of? This will now go, won't it? So now I've got that negative sitting up there. What does that negative represent? Negative 1. And that would be my answer. So let's try another one. Let's do this guy right here. So, can I factor anything out of 4x plus 12? When you factor a 3 out of 12, but you can't factor 3 out of 4. What can I pull out of both of those? A 4. right? All right. Can't pull anything out of x minus 5. All right, so what can I factor out of negative x squared plus 5x? Let me give you a hint. When you've got a negative in front, you should pull that out. What can I pull out of x squared plus 5x? An x, right? So if I pull out a negative x, what's left? X minus 5, right? We pulled the negative out, it changes the sign. Do you see why I did that? How I knew to do that? What factor did I already have in the denominator? I had an x minus 5, didn't I? So my idea was, okay, hey, if I pull that go ahead and pull that negative out, it's going to make it minus and it's going to match that other one. So keeping that in mind, what can I pull out of negative 3x minus 9? A negative 3. And what's that going to leave me inside? Good. So now, what can I go ahead and get rid of? X plus 3 will go. What else? All right, so what is left in the numerator? Do not say 4 minus x. Negative 4x. Good. You'd be surprised how many times somebody will rewrite that as 4 minus x. And what's left in the denominator? Negative 3, but we can't have two negatives, can we? So it becomes 4x over 3. Good. Now, here's the thing. We have a condition. Remember what I said, if we've got all the same, we've got to take and figure out what our denominator has holes in it, doesn't it? So what can my denominator not equal? Yep. So x cannot be 5 and x cannot be negative 3. And I'm going to leave it like that for now. Since it didn't specifically ask me to rewrite it, write my entire domain statement, we're just going to say x can't be 5 and x can't be negative 3. Okay? All right. How are we feeling about this one? Can you get rid of, look at this guy right here, 3x plus 6 and 3x minus 6. Will those cancel? No. Everything has to be the same, doesn't it? All right. But could you factor those and get rid of some stuff? Yeah, probably. All right, so let's keep going. We're getting close. How do you divide? Do you notice the steps are exactly the same? How do we divide? We do the same thing we've been doing, right? Rewrite as multiplication. This is the most important part, guys. Rewrite as multiplication. And then all the rest of the steps are the same as we were for multiplication, wasn't it? So let's look at one. If we have 2x plus 6 over x squared plus x minus 2 divided by x plus 3 over x squared plus 3x plus 2. Okay. Can we factor? Well, we can factor, but we don't need to factor yet, do we? What's step 1? Keep, change, flip. Keeping this. Changing this to multiplication and flipping this one over. Now we can factor. So what can I factor out of 2x plus 6? A 2. What am I left with? 2 times what? Good. All right. What can I factor x squared plus x minus 2 to? Sometimes it's easier to sit over here and go, all right, if I have negative 2 here and 1 here, what multiplies to give me negative 2 but adds up to 1? Positive 2 and, right? Multiply those two, you get negative 2. Add those two, you get 1. So this becomes x. All right. What about x squared plus 3x plus 2? 2 here, 3 here. It's going to be 2 and 1, isn't it? So this becomes all right. So what goes away? So my final answer is 2 times. Now, we got to figure out all the things that cannot be. So all the things that cannot be comes from this row, doesn't it? Think about it. This row, before it's simplified, tells me that x cannot be -2, -3, or 1, right? So everything before it's gone. So this final thing, this right here is my actual answer. The whole thing. And just put a comma there. All right, we have one last hurdle. And y'all freak out at this hurdle every time. It's like you see the word complex and you go, oh, can't do it. You can do it. Trust me on this. These are homework. Complex fraction. It is a rational expression whose numerator and denominator are rational expressions. In other words, it would be A over B divided by C over D. That is a complex fraction. Now, they look intimidating, but they're not because you've already done this. We just have to rewrite a complex fraction so it does not look intimidating. Example 1, x squared minus 16 over 8 divided by 4 minus x over 12. We are always going to take this and write it as division instead. In other words, we can take the top, x squared minus 16 over 8, and say instead it is divided by and now we know how to deal with it, don't we? We just did these, correct? Keep, change, flip. So all you have to do for a complex fraction is don't freak out about it. Just rewrite it as a division problem and then keep, change, flip. Okay? Another example. See if you can do this one and rewrite it on your own. So we have x minus 4, or x divided by 4 divided by 3y over 1. And why would I write it as 3y over 1? Yeah, so when I flip it, I know that it has to be 1 over 3y, right? This is one of those cases where if you don't do it that way, then you're going to forget and you're not going to flip it, or you're going to do something funny, aren't you? All right, so let's do an example. Wrapping up here. Let's look at this guy. So here's my example. X squared over 9x squared minus 4y squared all over x cubed divided by 2y minus 3x. So the first thing I'm going to do is rewrite this, aren't I? I'm going to rewrite this sideways. Okay? So change this into division. Make this a division, side-by-side division problem. So that's step 1. Change it to side-by-side division expression. Step 2 says we employ keep, change, flip, don't we? Okay, so we're going to keep. Do you get the feeling that these are mostly writing? I mean, they're not. They're long only because you have to keep rewriting the problem. And then we're going to flip this over. And now we can factor, can't we? So is there anything we can factor before we start canceling factors out? Where's the only place we can factor? Think about it, guys. Can't factor this, can I? Can't factor that, can't factor that. Can we factor this? Yes. Ooh. Oh, this should be a squared here, by the way. I dropped a squared. But yes, we can factor this. This is the difference of 2 squares, isn't it? So if this is the difference of 2 squares, factor it. What is it going to factor into? It's going to be what? It's going to be something plus and something minus, isn't it? Well, still going to be. What's the square root of 9? So this will be 3x and 3x. And then what's the square root of 4? So the other 2 pieces are going to be what? Yep, 2y and 2y. I dropped an x. I don't know why I dropped an x here. Here's an x, okay. All right. I dropped an x, I didn't mean to. All right, so what can I cancel? Guys, what can I cancel? An x squared. So that goes away. What else? There's something else I can cancel. What do you notice here and here? Ah, so if I can get rid of this and this if I put what in front of here? A negative. So that's what I'm going to do. I'm just going to throw a -1 in front here. And then I'm going to take and get rid of those 2. So what's left? -1 in the numerator. And an x times what?
3x plus 2y.
Yep. And I do not have to do anything. There's got more than one variable, so I don't even have to do my cannot equal thing, can I? So don't even have to mess with that. So we're done with that. Okay? We are right on time. This is what I'm talking about. Do not be intimidated by seeing stuff like this. It's just sit it side, unstack it, flip it over. As a matter of fact, guys, if you want to save yourself time, if you want to go ahead and when you're unstacking it, the top stays the same, and then you could go ahead and take this and do what with it? Flip it and multiply at the same time you're unstacking it, couldn't you? So you can combine keep, change, flip, and unstacking. So just unstack and flip the second half over and put a multiplication symbol in there, and you should be good. And then factor and eliminate factors. So all those problems we did not do, and then check understanding parts are your homework, okay? All right, they are not due, but don't put it off. They are not due until Wednesday. They are due Wednesday, so you've got a little extra time to work on them. Because what do I want you to do between now and Monday? Study for your test. If you've not worked out those problems on your review sheet, you need to. I'm going to post that review to Canvas just now, pretty much. I'm going to go ahead and post it to Canvas so that you can check your work, all right? As soon as I change out my stuff for them. change the command ceremony. Yeah. Oh, nice. Very cool. We'll all be going to change the command ceremony, so we're just, yeah. Yeah. It's important. The change of command ceremony is important. So what part of command structure are you? Yes, it is.
Is it so you can do physics, or
Yeah.
so you can do jokes about fun?
No, it's physics.
It's probably both.
It's,
You've made a joke.
is.
out of it.
Yes.
You got it?
yes, I have.
Listen, you know what you should do? You should carry that around with you, and if someone says, well, it's fun, just throw it.
No, you should be the one that says room pigs full high.
Because
You
they
should
do.
keep, no, you should keep saying it though, until people start saying it, and then you should do it.
I should.
Gotta wait
You are
till-
correct.
Until someone says.
All right, let me post this in Canvas before I forget.
We ain't got no quiz or anything in here, right? 'Cause I don't know.
Yes, I told you last time you were gonna have a vocab quiz. Remember all the vocab terms? You have to label stuff? Yes, I told you last time you would have one.
Oh, so we're not like, it's just labeling things.
Yes.
Oh, okay, I'm good.
Yeah, remember I said you're not, it's just working, it's a working quiz, like,
Okay.
I need to
thought
be
it
able
was
to,
like
yeah, no.
definition.
No.
Okay.
I don't, whether or not you know a definition really doesn't matter. It's whether or not you can use them in the context of the class.
Can I go ahead and do this?
Yes, absolutely. No notes or anything though. Get it doing. You got a quiz, so take it and sit. No notes or anything, just grab it and do it. It shouldn't take too long.
For some words, is there like more than